Okay, continuing with the log functions we talked about in class today, some of the basic properties of logs. And now we get to do the exciting task of graphing. Yee! All right, so graphing logs, I figured the best way to show you how to graph log is just to start with an example, and then I'll go over some general notes. One way you can graph logs, and it may make it a little bit easier, just kind of walk you through the first one, is I'm going to do some crazy hocus pocus stuff to this log function. Instead of saying y equals log base 2 of x, I'm going to say log base 2 of x equals y. Ooh, look at that trickery. Y'all catch that? I was real slick. I moved the y to the other side. And then you can actually take it out of log form. This is the same thing. We talked about this in class today. If you take this out of log form, that's the same thing as 2 to the y power is equal to x. And the reason I'm choosing to write it like this is because now I actually have the ability to make a nice XY table, and I could generate some points based on this equation to graph my log function. So let's just see what can we plug in for x. Ooh, this is going to be tough because if you plug in numbers for x, it makes it tougher to figure out things for y. Like, if I want to plug in 1 for x, if x is 1, I have to think, okay, 2 to what power of y is equal to 1, and that's kind of how we have to think. Well, 2 to the, well, maybe you know that 2 to the 0 is equal to 1. So if x is 1, y is going to be 0. Well, then let's see, what if x is 2? Well, let's see, 2 to what power? 2 to what power is going to be 2? That's actually not too hard either, is it? That would be 2 to the first power. So I could say y is equal to 1. So now I have a couple of ordered pairs. Let's try plugging in 3 for x. Let's see, 2 to what power is equal to 3? Ooh, yeah, that's where this thing starts to get a little bit more difficult because that's not easy to find. So what I'm going to do, instead of plugging in numbers for x, which is how we generally do things, I'm actually going to go crazy, and this is going to be backwards, but get ready for this. I'm going to plug in numbers for y. Because if I plug in numbers for y, like I've already done 0 and 1, if I plug in 2 for y, well then x is 2 to the second power, which is 4, and that's a lot easier to do. If I plug in 3 for y, x is 2 to the third power. 2 cubed is 8. It's a lot easier to generate your points. Now I don't have any negative y's. Let's try plugging in, say, negative 1. What happens if I plug in negative 1? Well, 2 to the negative 1 power, let's see, 2 to the negative 1, that's the same thing as 1/2. So my x coordinate is going to be 1/2. If I plug in negative 2 for y, 2 to the negative 2 power, that's the same thing as 1 over 2 squared, which is 1/4. So here I've got a whole plethora of points I'm going to graph. And if you notice all of these points, I have 0 negative x coordinates. All of my x coordinates are positive. So for this log graph, we actually are not going to need to even worry about negative x's. Everything's going to be on the right side of the y-axis. So let's graph that, and then we'll plot these points. Now we had the ordered pair 1, 0. We had the ordered pair 2, 1. We had the ordered pair 4, 2, and 8, let's see, 5, 6, 7, 8, 3. Then I had, when x is 1/2, my y-coordinate was negative 1. When x was 1/4, which is just right here, my y-coordinate was negative 2. And what ends up happening is this thing, as I go to the right, it's going to kind of level off and do something like this. As I move to the left, it drops down, and we have a vertical asymptote on the y-axis, and the graph does that number. So this is what the graph of a log function is like. And you could generate a table by doing that little 2 to the y equals x. That's going to be a little bit long, so I'm going to show you a few little quick ways that we can get the graph. Just some general properties of log graphs. For any log graph, log base b, regardless of the base of x, the graph is going to pass through the point 1, 0, and whatever the base is, 1. So 1, 0, and base 1. If you look at this graph, the base was 2. It went through 1, 0, and 2, 1. And then you also have a vertical asymptote at x equals 0, and x equals 0 is also known as the y-axis. So those are 2 things about log graphs, and this is before any transformations. If we shift or move this thing around, then the points are going to change. But before any transformations, this is going to be kind of our home base for our log graphs. So let's do a couple, or a few. Let's start with ln x. Well, I'm going to use those same general rules. I know ln x, that's a log with base e, right? Base e, and e is approximately, remember, 2.71828182845904523? But 2.7 is probably good enough. So I'm going to graph this. Let's get a y-axis in here. Let's get an x-axis. And notice I'm not going to worry about leaving much room to the left of the y-axis because log graphs always occur to the right of the y-axis, before a shift error or something anyway. All right, so I will start with the point 1, 0, and then whatever the base is, 2.7. 2.7 is about here, 1, so I'm going to hit that point. We have a vertical asymptote on the y-axis. So this is a vertical asymptote. And then I will sketch this graph. I'm going to follow my vertical asymptote, come up, I'll hit 1, 0, and then I'm going to start to level off. And there's our graph. That's the graph of ln x. Good, good? Good, 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 good. And that's your general shape of log functions. They kind of take off and with a vertical asymptote and level off a little bit. Now let's try log base 1/2 of x. Now this one's going to do something interesting. This one's going to do something a little bit interesting. Let's plot my y-axis. Let's get my x-axis in here. 1/2 is still going to go through those same 2 points. They're always going to go through 1, 0, and then whatever the base is, 1. Well, when you plot those 2 points, 1, 0 is right here, and 1/2 1 is actually up here. Now I said that normally log graphs will kind of have this general shape, right? Well, if I have that general shape, I'm not going to be able to come back and hit this point. So the shape of this one changes, and it actually comes down, and it'll hit those 2 points, and then it will kind of level off this way. We still have a vertical asymptote on x equals 0. So I still have this vertical asymptote. But instead of starting down low and coming up, since my base is a small fraction, we're actually going to start up high, and then we're going to come down, hit those 2 points, and then it'll kind of level off, do something like that. Yeah, yeah? Yeah, yeah? Questions, comments, concerns? Questions, comments, concerns? So if the base is less than 1, actually we'll say if the base is between 0 and 1, then you're going to have that general coming down shape. Yeah, that's kind of a weird note, but okay. Now let's see, what else do we have? Log base 5 of, ooh, what did I do with this one? 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 Transformations. So I threw in some transformations. So we're going to have to identify the parent function. We're going to have to identify a parent function, and then we're going to have to figure out some points for it. If I strip away all transformations, I'm down to the graph of simply log base 5 of x. And then the transformations, I see a +2 inside with the x, and then I see a -3 outside the log. So I have a transformation. The +2 is going to move me to the left 2 units. My -3 is going to move me down 3 units. Yeah, yeah. Yeah, yeah. Yeah, yeah. And then I'm going to start with log base 5 of x. Well, if you remember, log base 5 of x is going to go through the ordered pair 1, 0 and 5, 1. Whoops, forgot the 1. So I'll plot 1, 0 and 5, 1. We have that vertical asymptote on the y-axis. Good, good? Good, good? But then we need to start shifting things around. Each one of these points is going to go left 2 and down 3, and that includes the asymptote. So let's actually move the asymptote first. If I take a vertical asymptote and I move it left 2, it's going to end up right here. And then if I move it down 3, well, if it's a vertical line, you move it down, it's not going to move anywhere. So the vertical asymptote will go left 2, and then I'll take each one of these points. They're going to go left 2 and down to 3. This point, left 2, down to 3. And that's going to be my new graph. I'm going to come up, follow the asymptote, hit that point, and then we start to level off. Good, good? Good, good? Good, good? Good, good? How are we doing on time? 10 minutes, not too bad. I think there's only 2 more problems. So we're starting with those 2 points, and then we'll shift around as needed. Let's see, what about this one, negative 2 log base 3 of x? Again, there's a transformation, and I'm going to identify the parent function first, which in this case would be log base 3 of x. And I know that log base 3 of x goes through the ordered pairs 1, 0, and a base of 3, 1, right? All right, and then I've got to figure out what in the world does the negative 2 do. It's negative 2 times the function. Let's see, it's not inside with the x. That negative 2 is outside the function. That means I'm going to affect the y coordinates, which means I'm going to multiply my y coordinates by negative 2. So I'm going to do that over here on scratch paper. I'm going to do that over here. I'm going to take those coordinates and I'm going to multiply my y by negative 2. What's wrong with my writer thing? It's like losing sensitivity. There we go. All right, so my x coordinate is 1. If I multiply 0 by 2, it's going to remain 0. Then my x coordinate was 3. 1 times negative 2 is negative 2. And these are my new points to graph. That was my only transformation, so I'm going to go ahead and graph those. Let's get my axes in here. Y-axis, x-axis. Let's plot those 2 points. 1, 0. 1, 2, 3, negative 2. Ooh, my point flipped down. I do have a vertical asymptote on the y-axis. Let's draw that in there. There's no shift left or right, so my asymptote's not going to move. And notice this time when I multiply my y's by negative 2, it's going to flip this thing upside down. So now my graph, it's actually going to come down from up here and then start to slowly level off. Never quite levels off, but it looks like it. All right, so there's a graph for that one. So when you multiply by negative, when you multiply y's by negative, it will flip the graph. You good? You good? So there's number 5. Number 6, last one. Ooh, lots of stuff going on here. Lots of stuff going on here. I am starting with my parent function of log base 3 of x. So let's start with that, log base 3 of x. And I know that that has ordered pairs 1, 0, and 3, 1. And then we have to figure out what my transformations are here. You have to be careful, because look at this one. There's a 2x minus 6. You're probably thinking, okay, well, there's 3 transformations. I see the plus 1, I see the minus 6, and I see that times 2. Okay, the 2 is inside parentheses with the x. So that's 2 times x. But remember, if you affect the x coordinates, you do the opposite. So we are going to divide the x's by 2. The x's will be divided by 2, but where you might mess up is you see that minus 6, you may be thinking right 6, but before you identify any transformations, you have to see a 1x. So before I decide my shift, I'm going to pull a 2 out, still inside the log, but I'm going to write that as instead of 2x minus 6, let's change it to 2 parentheses x minus 3. Same thing. But now it's actually shift right 3, not 6. So my transformations, I will divide the x's by 2. Then I have a shift right 3, because I have minus 3 on the inside with the x. So I'm going to go right 3. And that's right here. And then that plus 1 on the outside, that's telling you to go up 1. So let's see, we have these ordered pairs. I'm going to divide my x's by 2, so my x coordinate divided by 2, and then my y coordinate, I didn't change those. Let's get my axes in here. So I have a y-axis, I have an x-axis, vertical asymptote on the y-axis. Okay, and let's divide my x's. So if I had an x coordinate of 1, divided by 2 becomes 1/2, 0. 3 divided by 2, 0. And I'll plot those points. So 1/2, 0 is right there. 3/2 is the same as, this should be 1. 3/2, 1. 3/2 is the same as 1.5, so 3/2, 1. Good. But then we need to start moving things around. I see a right 3 and an up 1. I'm going to start with the asymptote. Right 3, so 1, 2, 3 to the right. And if I move it up 1, it won't change because it's a vertical asymptote. Then these 2 points, I will do the same. right 2, 3, up 1. This point right here, right 2, 3, up 1. And here comes the graph. Follow that vertical asymptote. Hit those 2 points. And there we are. How do we feel? How do we feel? Good on graphs? Good on graphs? So that is graphing log functions. How long did that take? 15 minutes. Not too bad. We'll polish these up in class. Hope this makes sense.